So today, let's make an easy dustbin which everyone can do. If you have the right materials and right time. So let's look at what we have. So as you can see, we have a 9-gram servo attached to this monstrosity. So put it simply, it's a bent nail, and that is attached to the servo. Next, we need jumper wires, and then you need this breadboard, then an ultrasonic sensor, and the brain of it all, the Arduino Uno. So for the Arduino Uno, here we have two things. One, a 9-volt battery clip which can be connected to this, the 9-volt port, like this. So when we are finalizing with the dustbin, we'll most probably connect a 9-volt battery here to power the Arduino. And then we have this. This is the connecting cable which goes to my PC and to the Arduino. So as you can see here, there is a port. This pin over here fits right over here, just like that. So this would be done when we need to program the Arduino to tell what to do when the ultrasonic sensor sends something. So let's start. So first, let's take this, a red jumper wire, and if you look closely, there is VIN, ground, and 5 volt. Then there is 3.3 volt. We don't want that. Connect the red jumper wire to 5 volt. Since all these stuff need 5 volt to work. And then we need a black jumper wire, and let's connect this to G and D pin, and let's connect it here, and the anode over here. So the power supply is delivered to the breadboard. Next, let's take our servo motor, and when you look here, you can see 3 wires, a brown one, a red one, and a yellow one. There's one thing to remember: yellow is signal, red is positive, and brown is negative. So just like that, let's take any random jumper wire. So now I am taking the white jumper wire to the signal pin, and let's connect the signal pin to pin 2. So the servo motor would be connected to pin 2, and through pin 2 we would be sending the data for the servo motor to move, and that's how we would be lifting and lowering the top of the trash. Next, let's take another wire and let's connect this to the brown pin. Next, this goes over here, just behind the cathode. Next, we need another random wire. Here I have taken yellow, which is the anode. So this is connected here. So now the power supply is delivered, the signal is delivered, and the servo is ready. So next, let's take our ultrasonic sensor, and here we have a red wire. If you look closely here, there are 4 pins. This is a HCSR04 type ultrasonic sensor. There is another type which has 3 pins. So here we have trigger, echo, VCC and GND. So VCC will be connected to anode, GND will be connected to cathode. And now, so what these basically mean is, trigger is the trigger pin. So when we send a signal to the trigger pin, one of these emits a low frequency sound. When it hits an object and returns, the Arduino will calculate how much time it took between the trigger pin and the echo pin. So there we have the distance between the sensor and the object. So example, I want to put some trash in. So when I bring the trash bag near, the sensor will detect the object in front of it and the signal to the Arduino through the echo pin. And so the Arduino will tell the servo to move, which opens the lid. And then when we put the bag inside and move away, there is no object. So the sensor does not give any feedback. So then the Arduino understands that there is no object in front of it. So the servo goes back to its original position again. We can do some tweaks and changes to this. Example, if the ultrasonic sensor finds an object, we can use the delay to delay the closing, make it more efficient. So when this detects an object, the servo moves immediately and it pauses. And that pause will give us time to throw whatever we want to throw inside. And then when we move out, it will close. Let's not get too complicated. And when there's an object, it opens. And then we'd be standing in front of it when we need to put the trash in. So that's the idea main. Let's connect the blue wire to the trigger pin. And let's connect the trigger pin to pin 3. And the echo pin to pin 2. So now, when there is an object, the Arduino just randomly sends a signal through pin 2 to the trigger pin, and that allows one of these to produce a sound. which bounces off a random object and hits the other one. And then the ultrasonic sensor gives a feedback to pin 3. And then what the Arduino does is process the feedback, and if the feedback is that an object is near, then it will trigger the servo in pin 2, and that will move it 180 degrees like this. So that will retract and then extend. On to the coding part. See you there. So guys, now we are in Tinkercad. Here we have an Arduino R3, which is just an Arduino. Let's make the components all so that we can get all the stuff we want. We need this. So if you remember, echo was pin 3, trigger pin 2. If you forgot, we had a small breadboard. So the ground pin is here and the 5-volt pin here. Now the ground goes to the ground, the power goes to the power, and this is done. So next, if you look, we have these two guys. This one is a micro servo, and this is also a micro servo. But this is the micro servo which we have. It is a small blue one. So if we click on that, we have an option type. We can do this is the continuous type, but we have a positional type. That's why we can bend. We can bend. This goes on and on and on. So let's not do that. So if you remember, the power was on the power, the ground on the ground, and the signal. It is quite hard. Pin 2. Oops. I guess, yeah. Now it's right. So when we go to codes, so first we need to store the value which the ultrasonic sensor gives us. For that, let's name it Ultrasonic. So when you do that, you have these two options. Change ultrasonic by 0 and set ultrasonic to 0. And let's take this like input, and here we have this. It's a long code, but this toggles the ultrasonic sensor. So the trigger pin is pin 2, pin 3, and the echo is pin 4, and we want the units to be in centimeters, and so that is okay. And then need this if then else. So then let's click this math variable. If ultrasonic is, if it's less than 10. Sorry about that. So if ultrasonic is less than 10, then what this means is ultrasonic is set to the value of units in centimeters. So what this does is, it will calculate if ultrasonic is less than 10 centimeters, and if it is less than 10 centimeters, it can do something, or if it's not, it will do something. So these two somethings we must fill. And if you look, this, we have an option for that, and then pin 2. So the servo's signal pin is what it's talking about. And if it does happen, it goes 180 degrees. If it doesn't, well, 0. It's like that. So let's just check if this code works or not. Okay, nothing has happened yet. So as you can see, this dot represents the object, and when this guy moves, it's telling how far the sensor is from the object. Yep. So now, what this rotation means is, it is gonna close or open the trash bin. So when you leave it like that, it's like that, nothing. It's still. But when it goes out, it closes immediately. And so let's just do a small thing. Wait for 2 seconds. So this is needed since you may not be that close. So let's keep it simple, but I'll just show you. This would be much better. So it's far. Bam, trigger. And then, as you can see, it's slowed down. It's literally slowed down. Since we have this program running, this is kind of slow mode. So, throw that away. So, this does work. It does work. So what you need to do is, after blocks you have blocks plus text, and you have a whole bunch of code. Just copy all this, and then take the Arduino software, paste. So you have this here, and then it is connected here. Let's verify if this code will work or not. Done compiling. It's a thumbs up. So then we upload. That's it. Nothing else. And it's done. And the next step is assembly. See you there. You may be wondering, where is the can? The trash can, the literal body. We have a casing. Let's keep it here, and for now, let's disconnect the Arduino. If you didn't notice, it is unplugged. So don't worry. So next you have all these stuff down here. And then you take this guy, the ultrasonic sensor, and here it goes. If there is any object here, the signal will be sent to the Arduino, which will send and first process and then send the signal to the servo, who is sitting up here happily. And so he'll rotate, and that will push the top piece like this. So let's assemble it. So first, let's push all these guys down so that they take less to no space. Since we need to fill the rest with garbage, literally, we need a lot of space. And if there is food waste, well, please don't put it inside this. Seriously, everything is gonna fail. Or else you can do some other stuff which will prevent it from failing, and then, well, okay. So then, I guess you noticed this hook. Let's connect this hook like this. Here we have a small piece of paper which we would be placing it down here to collect all this garbage. As you can see here, we have a small piece of paper which acts like the collector, the garbage collector, literally. So what this does is, if there is any food waste or something, it stops all that liquid from seeping down and damaging the Arduino. So that's it. There's nothing else. And it looks quite cool when you can't see all that Arduino stuff. As you can see, this is it. It's the mini, easy to build trash can. So, shall we test it? So guys, we are at my PC. So here we have some garbage. If you don't have a PC, laptop or anything like that, you can even use a battery pack, which is very, very common. And I am pretty sure it'll power this up. So let's test if the trash bin really does collect trash. So, it seems it has worked. It does collect trash and it's a useful, easy to build project. Thank you for watching and see you in the next video.